Now that we understand a little more about objects, we're going to move into understanding one of the primitive objects, or one of the core base objects, which is the string class, or string. Eventually, we create string objects, and a corollary one, which is the string buffer class. So we know that we've created these strings before. We've done this a couple of times. We have the variable s of type string, and we assign it this is a string, where the double quotes encapsulating a sequence of characters is a literal string. Well, what this does is this actually creates an object. It creates an allocation of memory, and strings are basically immutable, which means you cannot change them. So what happens is this: if we do string s, this is a string. This is a string. This particular one creates an object in memory, and S is pointing to it. If later on I create a new string, it doesn't overwrite the existing set of memory. It cannot do that because it is immutable. It actually must allocate a new set of memory, put this as a new string, the sequence of characters within it, and then assign S to it. And what will happen is garbage collection in Java will then take hold. It will realize that this is no longer being used, and it will free up that memory by default. What string does is it does, as an object, it gives us some neat little functions. I've written some down here for you. I've taken this from, if you go to the Java SDK site at Oracle, you will see that a listing of the functions that are there. So you can use char at to return the character value at a specified index which you pass in. Concat, which concatenates a string to the specified end of the string. And this again will ultimately create a new object. Index of will return the index within the string of the first occurrence. One common one is length, where you want to return the length of a particular string. And you might replace characters, an old character with a new character. You can convert things to uppercase, convert to lowercase. Again, since strings are immutable, it is ultimately creating a new object. But for you using this, you really wouldn't know the difference. So here's a function that actually is a sample piece of code. We have string s. This is the string that I created. If you were to basically do system.out.println, using that object s, we could say s.char at 1, and it will return the value at the first location. If you did system.out.println length of string s, it will give you s.length. It will give you the full length of the string, and return this as an integer. System.out.println convert to uppercase s dot to uppercase will actually return a string that is all in uppercase. Now, string buffer, which is the other string class, is basically a different class, but it is not immutable. In other words, the object can grow or changed as needed. It will allocate the memory that is required. So it is a little bit different, and this gets into optimization techniques. But string buffer does provide a couple of other methods which are very neat. So it provides a couple functions like append, where you can append s to an existing string, buffer. You can also do insert, so I can insert characters between characters, and reverse will reverse the content of the string, or string buffer. So if we had a string buffer class and we did reverse on it, it would reverse the actual sequence of characters. So here's an example of its usage. Here's our main function. I have string s equals, this is the string that I created. Now note, with string buffer, I'm creating a variable sb of type string buffer, and this one I have to use the same thing that we'd been using before for creating of objects. So I must use the new keyword to create the new string buffer. I can then use the functions associated with it, sb.append s. So it will append this string to the sb object. And then I will do it again to add another one. And then I will reverse that SB object so that it will reverse the sequence of characters. And then I have my final output. Now you'll notice here that because we're using a string buffer class, the system.out.println doesn't know how to handle string buffer, and mostly because of this concatenation operator here. And so we must use the toString method. What it does is it converts SB to a type of string, so that the concatenation operator here, this plus, will actually work. Now, there's one other way to handle these methods. It's not very clean, but it's also useful if you're just doing something like we've done here, where it's fairly repetitive. This code is very easy to read, but what some programmers will do is they will combine everything together, and they will use objects and the results of those objects on the same line. And so I could refer to this as sb.append, which it will be this similar to this, sb.append. But then the result of that, I will then append another s, and then I will do a reverse, and then I will do the toString, which would basically create the output. So I could combine all of the items here into this one line to save space. Some people prefer it, other people don't. I actually prefer stringing out the code because it all gets compiled to the same thing anyway.